Good evening, guys. So let's wait for like few more minutes before starting today's session. So whoever is there in the meeting, please to stay, and we'll start the session in like 3 4 minutes. Good evening, all. So welcome to the problem solving session for the course Matlab Programming for Numerical Computation. This week we'll be looking at problems regarding just a second. Problems regarding regression and interpolation problems. So, as we used to do in our previous classes, first we'll do a quick recap of whatever was taught in the recorded lectures. So, in case you have any doubt, you can ask me, you can stop me, and then we'll discuss the doubts. Then, moving forward, we'll try to solve some problems which will help you solve your assignment questions. So, let me start the session. In case you have any doubt, you can just unmute yourself and ask, or else just put it in the chat box. We'll discuss them. So first we are discussing two important things. One is regression, the other one is interpolation. So first it's important that we understand what is the basic difference between these two. So for that, just a second. So for this first, regression is basically obtaining a straight line that is best fit the data. So for example, if you have these points like this, you can see the points here. Okay. We need to find a straight line that can balance the errors. For example, if we can see the straight line that we draw here, okay, this straight line, whatever is drawn here. So compared to this line, this error is towards this side. So let us imagine this is a negative error. Okay. So this is a negative error. Here you have a positive error, and again you have a positive error, negative error, positive error. So what the main agenda is, we need to find a straight line that can balances out the errors. Okay. So it might not be possible to get it accurately. So based on that, you have like best fit regression fits and all you'll be having. So among what is possible, just a second. Yeah. Okay. Within what is possible, we'll try to find a best fit linear curve that passes through all the points. So this is a straight line that we have. It will try to balance out the error. So that is why you can see this line is between your data points. Okay. This line is not here or here. It is between the data points in such a way that it balances out. It is like it balances out the errors of these points in such a way that it is close to the given data point. Okay. Next is interpolation. So interpolation is basically joining the dots and find a curve passing through the data. So for example, here in the regression, you can see this is a best fit data, but this line is not passing through your data points. Okay. So, but for interpolation, what you do is you'll have to join the dots like this. These two dots are joined, and these two dots are joined like this. Okay. So basically, why do we do regression or interpolation? Regression is you have a model function. So you have, if when you're doing experiments, you have like a X data and a Y data that you get. Okay. So this data you're getting using regression. So now what we need is you need to find a function like f of X, okay, which is called as Y. We need to find this function that can model your experiment. Okay. So if you need to find a function that captures how your model behaves, then we use regression. So on the other hand, if you want to find the missing data points, for example, uh, just a second. So for example, here you know what the value is, here you know the what the value is, and at this point also you know the what the value is. Imagine that you need to calculate what is the value at this point. So that is here. So what we do is we interpolate between. So we interpolate between these 2 points. That is this curve that you see is the interpolated point, and corresponding to this x value, you see what is your corresponding y value. That will be here. Okay. So interpolation is we use when we want to find the missing data points, and regression you use when you want to find the model function for your experiment or whatever data you have when you want to find a model function. So this is the basic difference between regression and interpolation. Now, moving forward, we'll see some of the methods that can help you find the regression and interpolation answers. So, for example, first let us look at linear regression. What is linear regression? We are trying to fit a straight line. So this one was a linear regression. Okay, you can also do nonlinear regression, which means you can fit a nonlinear curve in such a way that it minimizes the errors. Okay. Now, first, what we are discussing is a linear regression. So your function, the function model function should be in the form of a linear straight line. That is y1 yi is equal to a0 plus a1 xi. You know what this is? This is like a equation of a straight line, that is y is equal to c plus mx. I'm sure that you would have seen this formula before. That is y is equal to c plus mx, where m is the slope, c is the intercept, and this is how you can map your x and y value. Similarly, what happens is this is your function yi is equal to a0 plus a1 xi, where a0 and a1 are constants like c and m. These needs to be found out. So when you start this question, you have a certain value of xi. So when you start, you have x value and corresponding y value. You have like I equal to 1, I equal to 2, I equal to 3, and so on. You have your x data and the corresponding y data. This is what you have when you begin your calculation. And a0 and a1 is what we need to find out at the end of the calculation. So this is called as linear least squares method. Actually, the formula is only given to you in the recorded lectures. I am just showing you the derivation here so that it will help you understand better. So let us calculate. Let us take this as a model function which we need to find. yi is equal to a0 plus a1 xi. Now let us find the error. What is the error? So this yi is actually the true value, right? The true function value which is provided by the user. Okay. This yi is a true function value. What is this? This is the function value of xi when you are modeling it using linear regression. This is a0, a1x is the model. So this is the true and this is the model value. We need to find the error. What is the error? Error is basically true value minus the model value. So you can bring the whole thing to the other side. Just a second. Yeah, you can bring the whole thing to the other side. Mm, yeah. You can bring the whole thing to the other side like this. And then what do you get? You get yi minus a0 minus a1 xi. Okay. So now when you there can be positive errors and there can be negative errors. That is when you subtract this quantity from this, when you subtract true minus model, it could be plus sign should also can also be there, minus sign can also be there. Okay. We're not worried about the signs here. So because we want to remove the sign, let us square it. Okay. So yi minus a0 minus a1 xi, we take the whole square of it. So this is the error term. Now what we need to do is we need to minimize this error term. How do you minimize a function? So to minimize a function, first what we need to do is we need to calculate the derivative with respect to the unknowns. This is like a traditional method that we use in mathematics when we have to minimize a particular function. Okay, so you have the function which has to be minimized. You know the unknown quantities are a0 and a1. So let's take a derivative of this quantity with respect to a0 and a1. So this is a derivative with respect to a0. When you take the derivative with respect to a0, you know that it is just a positive quantity. So this is basically in the form of like x square, right? So what is the derivative? It will be 2x. Okay, so this 2 will come here. You have the 2 here, and you have the quantity, the x, so that is yi minus a0 minus a1 xi. And why is this minus sign coming? Because the coefficient of a0 is a negative. Okay, this negative will come here. Coefficient is negative. So So I hope you have understood this one. Okay. Now what do we do? So the sigma term, the summation term you take inside the bracket. This you have to take it to inside the bracket. Now when you take it to inside the bracket, what will happen? So this you have to equate it to 0. Take it inside the bracket and equate it to 0. When you write it, this one equal to 0, this minus 2 can be cancelled because that's a constant. When you equate it to 0, that can be cancelled. Now when you take the sigma inside, what will happen? This will become sigma I to n yi. So that is this term. Okay. That is this term. Okay. Now here what will happen? This will become sigma. So this will become minus I equal to 1 to n a0. Okay. You know a0 is a constant, right? So, okay. I think that part has not been, that will simplify later. But anyways, so this is sigma a0 here. Okay. So this term is here. And this term is what? A1 xi. Since A1 is a constant, it can be taken out of the sigma. Okay. And you just have sigma I equal to 1 to n xi. So this term is here. Okay. Is this clear how this has been written like this? You have, since this minus signs are there, you can take it to the other side, then it becomes plus signs. Okay. So this is the derivative of this error with respect to your first unknown quantity, that is A0. Now let us take the derivative of this function with respect to the second unknown quantity, which is A1. Now what will happen? This a1 is a coefficient of xi. Okay. So how will you do it? So this one we'll have to have this minus this 2 power will come here. Okay. And then you have ya minus a0 minus a1 xi. That term will come here. And what is the derivative of a1? There is a coefficient xi. So that will also have to be multiplied xi. So this is the whole thing. Now let's take this xi to inside the bracket. Now what will happen when you take xi inside the bracket? You will have yi xi minus a0 xi minus a1 xi square, right? This is what you get. Now you can take the sigma inside, and since you're equating it to 0, when you equate it to 0, this minus 2 also will get cancelled. Okay. So now let us equate it to 0 and take the sigmas inside. Now it will become sigma xi yi. So that is this term. Okay. So this term is here. Now minus a0 xi. Since a0 is a constant, it can be taken outside the sigma. So this one is here. And a1 xi square. Since a1 is a constant, it can be taken. So this one is here. Okay. So likewise, now we have got two equations. Okay. These are the two equations we have got. Now we need to solve the two equations. So you know how to solve these two equations. It is in the form of, so this is the total thing. Okay. And one more thing I can say is, since a0 is a constant, this a0 can be taken outside. So it will be become a0 sigma I equal to 1 to n. The coefficient is 1. What is this? This can be also written as a0 n, right? So it will be sigma will be to 1 to n. Okay, it will be written n times basically. So you'll have 1 plus 1 plus 1 plus 1. Basically, it will be written n times. So the sum is a0n. Okay. So this is what you do. Since now you have like two equations, two unknowns, you can write it in the form of a x is equal to b. Okay, the standard form in which you used to write. What is the A matrix? A matrix will be the coefficient matrix. So the coefficient matrix here is, okay, first let's take the unknown. Unknowns are A0 and A1. Now we'll make the coefficient matrix A. The coefficient here is n. The coefficient here is this whole thing. That is sigma I equal to 1 to n xi, this term. Then for the next row, it will be the coefficient is this, that is this part. And the coefficient is this, that is this part. Okay. Now we have got the coefficient matrix. Now what is your B vector? B vector is basically this part will come, that is here. This part will come, that is here. Now we have got in the form of Ax is equal to B. Now what do we need to find out? We need to calculate this x. That is basically you need to calculate A0 and A1. How do you do that? X is equal to inverse of A multiplied by B. You will be getting what is your A0 and A1. Is this clear? So this is basically the derivation. The only important thing is if you can remember this formula, it is well and good. You don't have to do all the derivations. I'm just telling you how this has been done. Okay. So we have a model equation. We find the error between the true value and the model function. So we have the error equation here. You are squaring it because we'll have both positive and negative errors. Okay, we are not bothered about the sign. So because of that, we are squaring it. And then you take the derivative with respect to the unknowns. So that is derivative with respect to A0 and derivative with respect to A1. We'll end up getting a matrix equation like this. And you can use Ax is equal to B, then x is equal to inverse of A multiplied by B. Okay, so that's how we find it out. So now we are given an example question. X values are given and corresponding Y values are given here. We need to fit a straight line, and that is basically you need to find the coefficient A0 and A1. So now let's try to do that. Just a second. I hope you can see Matlab. So this is the function. I've already coded this. X value and Y value has been written here. Now let's see how many data points you have. So that is n length of X will give you how many entries are there. That is 1, 2, 3, 4, 5, 6 entries are there. So capital N is equal to, this is N is equal to 6. Okay. Now we have to create the coefficient matrix. Okay. If you remember the coefficient matrix, what was it? It had n data points. So n here is equal to 6. Okay. And the next entry was sum of all the x values. So that is what is written here. Sum is an inbuilt Matlab command which will give you the total sum. So this will be sigma xi, right? And again here we have sigma xi. That is again sigma xi here, sum. Okay. And the other formula, it was sigma xi ya. So that one is here, sigma x square, right? Xi square. I made a mistake. Okay. Sigma xi square. So this is your A matrix. That's what we make here. N sum of x. In the next row, we have separating it with a semicolon. In the next row, we have sum of x and sum of x star x. Y dot x. Okay, you can't do matrix multiplication because both are vectors. So that is why you do point wise multiplication. Okay, x dot star x. Now we need to make the B matrix. Okay, so B matrix is the sum. Y first value is just a second. Yeah. First value is sigma yi, and the next value is sigma xi ya. Okay, so that's what we write here. So this one is sigma y, and this is sigma xi ya. Now we have made your A matrix and your B matrix. Now your phi is nothing but inverse of A multiplied by B. You will be getting, okay, I'll just run this code here. Let's see what's the answer we are getting. We get phi. Okay. So in this phi, understand that the first phi is A0 and the second phi is A1. Okay. So now if you want to plot it, this will give you the scattered plot. That is x comma y, that is this data. You are making it in blue squares, so this will be a scattered data. Now I want to draw a line, straight line. So for the straight line, what I do is I just take two x values, for example 0.6, 0.4 and 5, and I calculate the corresponding y value. So how do I calculate? The function form is the first coefficient, that is a0 plus a1 x. Okay, this is my function value. So a0 is here, 5, the first entry of 5. This is a1, the second entry of 5, and this is my x, 0.4265. I get the straight line, and that I am plotting with a red line. So let's try to see what the answer is still here. Okay, evaluate selection. You will get a plot like this. Okay, this blue squares are the scattered points that we had in the table, and this red line is the linear regression line that we got using the method of least squares. Any doubts in this so far? Okay. If not, then let us move to the next method. Just give me a second.
Hello, ma'am.
Yeah, yes. Ask me.
Ma'am, that last line, can you explain it again? That plot of x comma y comma that one.
Okay, just a second. Yeah. This one, this line, plot x comma y. Okay.
Yeah.
So plotting a straight line, you only need 2 points. Okay, you already know it's a straight line. So what I'm doing is my plot has to be for the 2 points are 0. Just a second. Okay, my 2 points for plotting a straight line, I just need 2 points, right? When I know the 2 points, if I just join it, I'll get the straight line. So first for this point, I'm taking, let the x value be 0.4 and this x value be 5. And if you ask me why am I taking it, that is because here you can see the x value starting is 0.8. Okay, I can take 0.8 also. It doesn't make a difference. Okay, and the largest value is 4.9. So let me take here 5, something close to that. I can also take here 4.9. That is also completely fine. Okay, here I've taken 5 instead of 0.8. I've taken 0.4. Now what I do is, this is my x value and I need to have the corresponding y value because that's how the plot function works. You need to give plot x comma y. So now what is a plot y value here? For 0.4, the function will be, so if my x value is 0.4, my y value corresponding to is a0 plus a1 multiplied by 0.4. And the y value corresponding to when x is equal to 5 is a0 plus a1 multiplied by 5, right? So that's exactly what has been done here. You will get two values here. Okay, if you want, I'll just evaluate this thing and show you. So this is your function. This is the one corresponding to x is equal to 0.4 and this is corresponding to x is equal to 5. So here we have given two x values, two y values. When you give it to the plot function, you will plot a straight line that is joining the two data points. That's how it will be done.
Okay, ma'am. Thank you.
Yeah. Instead of this, if you just plot here maybe 0.3 to maybe 8, and here also you'll have to change 0.3 to 8. Let me run the plotting function. So you can see the red starts from 0.3 and the red line stops at 8. X is equal to 8. Okay, that is how long the red line is. So I don't want this much point because my data is not there. So what was it? 5, right? Yes. Now the next method we are looking at is the Newton's divided difference. So when you see this formula, it might be a little overwhelming because there's a lot of equations. So let me just tell you one simple methods to understand. So if we have a function like this, f square bracket x1 x0, it means that it is f of x1 minus f of x0 divided by the difference of these entries, that is x1 minus x0. So this portion, sorry, this portion f of x1, f of x0, and then you have the difference of it, that is x1 minus x0. Similarly, if you have f of x2, x1, this means f of x2, that is here, f of x1, that is again here, and the difference between these entries, that is x2 minus x1. When you have three values, x2, x1, x0, this means that you will have to calculate the difference, that is f of x2, x1, that is this one, f of x1, x0, that is this one, and the denominator, what you do is you have to take the largest difference, that is your entry should be at the two ends, that is x0 and x2 minus x0. Okay, and for this entry, what do? You take f of x3, x2, then f of x2, x1. Okay, and the difference will be between x3 and x1. Okay, and this one, this one obviously will have a formula like this. This comes from here. Sorry, not this one, here. Not this. Okay. Sorry. Yeah. So this equation will come from here. Okay. So this is how neuter divider difference is done. It might be difficult for you to understand. So what I'll do is I'll just show you with an example. Okay, this is how it's done. So for example, if you have x1, x2, x3, so values like x's, and you have your function value f of x0, f of x1, f of x2, f of x3. This is how you should calculate the Newton formula. That is, first you take this difference. Okay, so that is f of x1 minus f of x0 divided by x1 minus x2. That is f of x1 minus f of x0 divided by x1 minus x0. Okay, you do it, take this, then you take this difference. This is f of x2 minus f of x1 divided by x2 minus x1. And here this will be f of x3 minus f of x2 divided by x3 minus x2. Okay, so now you get this one. Afterwards, there is no entry. So you start with 4 entries in the first column, and the second column you will reduce to 3 entries. Okay, now you let us go to the next column. So this is first column, this is second column, third column. Now let us go to the third column. In the third column, what do? You calculate the difference between these two values. Okay, and the denominator, what do? You see the largest entry is x2 and the lowest entry is x0, right? So the denominator will be x2 minus x0 here. Now let us take this difference. The difference between these two function values, and what will be the denominator? It will be x3 minus x1. Okay, that is the largest entries. Now you've got the third column. Now again, you can see in the third column also there are 2 entries. So we have one more column, which is the fourth column. Okay, in the fourth column, what do? You calculate the difference between these 2 entries. And what will be the denominator? The largest entry is x3 and the lowest entry is x0. So that is x3 minus x0. Now after doing this, what will happen? There is no, one more entry is not there. This only has one entry here. So when you reach to one entry, you just stop it. Okay. Now whatever you get here, that is this value, whatever I've written in the red lines. Okay. These ones. Okay. These are called as the coefficients. F of x0, f of x1, x0, f of x0, f of x1, x0, f of x2, x1, x0, f of x3, x2, x1, x0. These terms are the coefficients. And to the coefficients, you have to multiply something. What do you multiply? With f of x0, you don't have to multiply anything. With this term, f of x1, x0, you multiply x minus x0. Okay, that is this entry, x minus x0. To the next entry, you have to multiply x minus x0 multiplied by x minus x1. Okay, you can see a pattern, right? So this is x minus x0. Now you have one more term, x minus x1. To the next term, what do? You subtract, you multiply x minus x0, x minus x1, x minus x2. So finally, what will happen when you do this? You will be getting a function. Okay, to that function. So now my question is, find P of 2. What do you do? In this equation, you know all these values. F of x0, you know, this value you know. The only unknown in this equation is x. You don't know what x is. You have to just substitute x in that position. You will be getting what is P of 2. Okay. So this is how you do neuter divided difference. This is for interpolation. Okay. So I'll show you one example. With that example, you'll be able to understand. So this is the question. You have the X1 data, you have the Y data. Okay, so let me first write this as a column. So I have my X values, this is my X values, and this is my Y values. Okay, first I'll take this. You can do along with me, okay? Just check if I'm doing the right thing. First, let's take this difference. Okay, so this is minus 48 minus 46 divided by, uh, sorry, it has to be the other way around, right? Sorry. Yeah, when you take this one, it is minus 46 minus 48 divided by 2 minus 1. Are you getting 2 as the answer? Just check. Okay. The next is this entry. You get 12 minus 46 divided by 4 minus 2. Are you getting 29? Okay. And next is you take this one. This will be 92 minus 12 divided by 5 minus 4. You should be getting 80. Okay. So now the first column is done. Now second column is also done. From the second column, we have to make the third column. How do? You calculate the difference between this, okay, divided by what will be the maximum entry here. So this will be, for this, it's important that you understand the formulas, okay? This will be probably, this comes from here, right? So the difference denominator will be 4 minus 1. That is this one minus this one, okay? For this entry, the maximum denominator will be here. And the minimum, I think, is 2. So I think this will be 5 minus 2. Okay. So you have these two entries. Now what will be the difference? 17 minus 9 divided by 5 minus 1. That will be the denominator. Okay. That is, check, is 17 minus 9 divided by 5 minus 1. What is the value? You will be getting 8 divided by 4, which is 2.
Correct, ma'am.
Yeah. So now let me divide all this. So now this, and this 4 values. These are my coefficients. So with the first coefficient, you don't do anything. With the second coefficient, I have to multiply x minus the first entry, x minus x0, right? So x minus x0, this is x minus x0. With the next coefficient, I have to multiply x minus x0, x minus x1. That is, in my case, it is x minus 1 and x minus 2. This is my next coefficient. Okay. With that, what do? I multiply x minus x1, x minus x2, sorry, x minus x0, x minus x1, and x minus x2. So x minus 1, x minus 2, x minus 4. Okay, that's it. I all my 4 coefficients, I've used it. So that's it. Now finally, I get, when I simplify, I get this equation 2x cubed minus 5x squared plus 3x minus 48. Now, if I want to calculate what is the value, function value at x is equal to 2 or 3 or something, you have to just replace that in this position of x. You'll be getting the function value. Is this clear? Any doubts?
No, ma'am. No doubts.
So now let's do this question. So this is a question. You can should I give you time to do it using pen and paper? I'll do one thing. I'll just show you the MATLAB code for this. Okay. And so when you don't have, like, you may not have access to MATLAB always. So try to do this using pen and paper and just confirm if you're getting the same answer. Okay, I'll share MATLAB. Okay. Now the same question. Okay, this is the same question. X and Y values are given to you. Total number of entries is 6. That is also given to you. Now this is how the neuter divided difference starts. I don't know if I have time to explain the code in detail, but I'll tell you, like, this has been shared to you in the recorded lectures, okay? But I'll tell you, like, line by line what is happening. So just in case you don't understand, you can just ask me, or else you can take your time and then see what is happening in the code. So let's do it line by line. Okay, CLC. So I'm just running this here. Okay. So you can see your x values here, x values, y values, and n is equal to 6. X values, y values, n is equal to 6. Now, this is the code where it starts. Okay. So I want to find the interpolation for several points. Okay. Instead of a single point, I'm calculating the interpolation at all these points. These are the points where I need the interpolated answers. That is this. At 0 0.8, 0 0.81, 0 0.82, and so on. These are the finer grid that I have. I need to interpolate and find what is the function value at all these points. Now what I do is, first let me initialize every value to be 0. So this is my x int, okay? And y int, I am declaring all the function values to be 0 initially to begin with. Now what I do is, I run through a loop, okay? 1 to the last x int. And this correspondingly, my yin gets replaced by this function. Whatever this function is calculating, that gets stored in this corresponding y values. Now, this is the important part of the code. NDD, this code. This gives you how the neuter divider difference is calculated. So for calculating this, what all you need is, you need the x and y data that is given to you in the question. And you also know the points at which you need to interpolate the value. That is x int. These are the points where you need to find the y values. So these many inputs are given. So first, let's see what is the length of the x value. Okay, that is 6. Okay, length of the x, six entries are there. So first, let me make a matrix with all zeros, 6 by 6 zeros. Okay, so this is the matrix. Okay, the idea is the first column of the matrix, I'll make it like the first column, whatever I wrote during calculating with pen and paper, right? So that column, I'll make it here. The next column will come here, third column will come here, and so on the columns will go. Now, first is, the first column is nothing but your y value itself, straight away your y value. So let me write that. I am writing call D is equal to y value. So that is this one. Okay, this is my first y values. And I'm telling in the D matrix, my first column should be this call D. Okay, I'll run this also. So what happened is, it was a 6 by 6 matrix with all zeros. Now I made the first column my y values. Now I need to calculate from this column, I need to calculate the second column. Okay, so for that, there we are creating a for loop here. So this automatically calculates your other rows. This might be a bit complicated. You need to understand how this n plus 1 minus I, how these indexes are working. But the basic idea is, diff call D means it will calculate the differences between not consecutive entries, not alternative, consecutive entries. For example, if I use, if I use diff call D here, what it calculates it calculates the difference between these two entries, these two entries, these two entries, these two entries, and these two entries. Okay, that's what the inbuilt MATLAB command diff does. Okay, so now that is basically the numerator part, right? And the numerator was always f of x1 minus f of x0, f of x2 minus f of x1. So that is automatically done by this diff command. Now we need to divide it by the corresponding denominators. So that is a tricky part. I'm not going to this in detail. What you can do is, for every I value, just write and see if this is giving you the correct entry. Okay, it will be giving you the correct entry. For example, I can just try it once when I is equal to 2. Okay, so I'm trying I equal to 2, the first entry. I'll show you what this call D looks like. I'll just run this. Okay, this is what the call D looks like. Now what I do is, I replace the next column by call D. So this looks like this. So initially I had like 6 entries. Now I make 5 entries here. So when I run this loop, what will happen is, this is how the matrix looks like. Sorry. Here. Sorry, 1 minute. Run it from here. Okay. This is how my matrix looks like. This is the first column. Visiting this first column, I made the second column. With second column, I made the third column. And finally, there will be 6 columns will be there. In the sixth column, by the end of sixth column, I'll only have 1 entry. Okay, now no more computation I can do. Now here, what are my coefficients? Coefficient will be, this first row will be my coefficients. So I'll take the coefficient as D, first row, all columns. That is all this entries. This is my first column. These are my coefficients. Now with the coefficients, I have to multiply. With the first coefficient, I don't have to multiply anything. Okay. So the first coefficient, I don't have to multiply anything. So I'm just multiplying it with 1. In the second coefficient, you have to multiply. The first entry will be x minus x0. Next will be x minus x0 multiplied by x minus x1, like that. So the easy way to calculate is there's an inbuilt MATLAB command which is called as cumprod, which is the cumulative product. Okay. So for that, you can give your entries like this. This also is a bit tricky, but you need to, what you can do is for n minus 1, you can just expand this. Okay. Write it step by step what it calculates. Okay. So I can just run this for you. I think I have to run this code together. Okay. But basically, you will be getting, the uh, coefficients here and whatever you have to multiply, and then you will be getting multiplying the coefficients versus the entries. Okay. Now I'll just run this portion. Just a second. Oh, sorry. I have to run the whole thing. Okay. Now what happened is in the code, sorry, in this code, if you see regression, this code, okay, I got the y int for the corresponding x in values. I got the y int. Now I am plotting it. X and y, whatever is given to me in the question, I'm plotting it as like scattered plot with blue squares. This is my x int and y int, whatever I got with interpolation. I'm plotting it with the dotted K means black color. Okay, dotted black line. Okay, so the plot looks like this. This blue dotted points are my scattered points, whichever I had given by the user. This red was a regression line that I calculated using the fit linear least squares. Now this you can see, this curved line is the interpolated line. As you can see, this is passing through all the data points. The earlier regression line was not passing through all the data point. Okay, so now you will be getting the interpolated curve. Any questions? Any doubts? Okay. So since you don't have any doubts, let me just move forward to the next point, next topic. So just give me a second. This is linear regression with multiple parameters. So earlier what we saw only had A0 plus A1x. Only this portion was there. Now what if we have like more parameters? So here we have x1, u1, w1. There are 3 variables and it is y1 is the function value. So but still it is like linear with respect to x, linear with respect to u, linear with respect to w. So this is linear regression with multiple parameters. So for this also you can use linear least squares. I'm not going into the derivation and all, but this is the final formula. What you have to do is you have to create a capital X matrix. Well, how does a capital X matrix looks like? The first column will be all ones. By default, it is all ones. Why? Because it is the your function is of this form. Y0 is equal to A0 plus A1x plus A2u plus the A3w. The coefficient of A0 is 1. So 1, 1, 1, 1, 1. The coefficient of A1 is x, right? So how many x you have? X1 is there, x2 is there, till xn is there. So x1, x2 up to xn. The next is coefficient of A2, that is u. We have u1 to un. That will come here u1 to un. Next coefficient of A3 is w. W goes from w1 to wn. So w1 to wn. So now you have made your x matrix. What is your phi matrix? That is the unknown matrix is A0, A1, A2, A3. Okay. And this is your final matrix where you have y1 to yn. y1, y2 up to yn. So once you have made the matrix like this, for finding phi, you can use this formula. That is x transpose x whole inverse multiplied by x transpose y. You will be getting a vector of phi values. Okay. So this is a function. Let's try to do that. Okay. You have your x values. Uh, yeah. Just a second. Look here. Yeah. So here you have your x values and y values here. Okay, x and y values. How many entries you have? Length of X data is 6. So first let me make the matrix. Okay. The matrix is, it will be all ones followed by X values. Okay. Here my function is only, okay. Here I only have two columns. I just have one X and Y. So it will be like A0 plus A1X. A0, the coefficient is 1, so I'll have lot of ones. And coefficient of X1 is A1 is X, so I'll have X1, X2, so on. Okay. So that is here ones, and these are my X values. Okay. This is ones, and these are my X1, X2, X3 values. Now what I do is my Y vector is nothing but Y data, straight away Y data. Now let me find phi. Phi is nothing but whole inverse of X transpose X, okay, whole inverse multiplied by X transpose Y. So I'll run this here. My phi is like this. A0 is 0.4375 and A1 is 0.4698. Earlier, as we did earlier, let me plot x1 and x2 using the scattered blue squares. And the same thing, I'm just plotting here from 0.5 to 5. You can also have a different limit, that is completely fine. And I'm plotting the straight line, phi1 plus phi2, 0.5 to 5 using a red line. So let me run this together. See, I'll get the same straight line that I got earlier. Okay, you'll get the same straight line, regression line. Okay. Now, the next method that we need to look forward is a inbuilt Matlab command, which is called as LSQ curve fit. Rather than using these formulas, Matlab can automatically do it for you. So that function is called as LSQ curve fit. It has a syntax. We need to follow that syntax for making it work properly. So phi is the output that you get, right? So the phi is equal to LSQ curve fit is a keyword. And you're telling the variables you're looking for is, you need to solve for phi, and X data is given to you. Okay. And this is the function. This is a particular function. Right now we have just named it fname. It takes in two inputs. What all input it takes, it tells you which all variables I need to solve for. And it also takes the, just a second. It also takes the X data. It will tell you which all variables I need to solve for, and it also takes the X data. P0 is basically the initial guess for phi. Okay, this is a MATLAB solver. So you need to give a good guess for phi for this to begin with itself. So this P0 is the initial guess for phi. X data and Y data is what you get from the question. So now we'll see what we have to do with this fname. Fname provides a Y model. So for example, if I need to model a function using this formula, A0 plus A1X, this function, basically fname function, fname should give me this. This should be the output. This should be the output. Okay, it should give me the model function itself. Okay, LSQ curve fit, what does it internally do? It minimizes the error between your Y data and your model function. Whatever the user gives, and the model function will try to minimize the error. Okay, just like you do for the method of linear least squares. So let's try to do the same problem using LSQ curve fit. Any doubts?
No,
If
ma'am.
yeah, if you don't have any doubts, please mute. Okay. Yeah. So this is how you do it. Phi, right now, since I've already used phi here in the before, I'm just using this variable to be phi1. I'm using the keyword LSQ curve fit. Okay, this is an anonymous function. So I'm just telling, so this function I'm just telling phi is the variable I need to solve for. X is the unknown quantity. Okay. Uh, sorry, X is the data. Now, this is my function name, mylin example. It takes in phi and X is the input. So let me look at phi. It takes in phi and X data as the input. And this is my model function. My model function is phi has two entries, A0 and A1. So this is A0, first entry of phi. A1 is second entry of phi, and that has to be multiplied to the X data. You can use different variable, okay? You can also use your X, that is also completely fine. And this is the output. F1 will become my output. This model function is my output. Now going back, now I'm giving initial guess for phi values. That is initial guess for A0 and A1. I'm just both giving 1 and 1. I can give any different guesses also. Right here, I'm just giving 1 for A0 and 1 for A1. And this is my X data and Y data for the question. Hello? Who is this guy? Danish? Yeah. Okay, you have X data and Y data value. And the same thing, I'm plotting the scattered value. And for 0.5 to 5, I'm using this phi 1 and phi 2, and I'm plotting it using dotted black line. Okay. Now what will happen is I'm running the whole code together. So this is using curve fit, and this is using the linear least squares, and this is using LSQ curve fit. Let me run both together. So here, this is the curve I get. You can see here it has been said that multi-regression local minimum is found. That is LSQ curve fit has run and the minimum is found. Local minimum found means the value of phi which reduces the error. Okay, that has been found. And this is the curve looks like. So this is scattered points you have, which we had earlier. This red straight line, we got it from the method of least squares. Now, this black dotted line that you see is what you got using LSQ curve fit. You can see both the lines are same, exactly matching. Okay, because LSQ curve fit also tries to minimize the error, just the way we derived the method of least squares. Okay, you will get the same answer. Now, do you have any doubts? Okay. If not, let me move to the next topic. Okay. So this is, so far we saw linear regression, right? So always our function was in the form y is equal to mx plus c. What if we have a nonlinear function? So for example, here you have a table that is for different mole per liter, different concentration and different Kelvin temperatures, you have different reaction values. Okay, 1.48, 1.65, there are like this, it's a function that is, okay. This you have like rate, which is a function of concentration and temperature. Okay, that's how it has been coded. And now how are they related? This is not related linearly. The R is related to T and C by this function, K0 e raised to minus e by RT c raised to n. So this is a nonlinear function. It is nonlinear with respect to temperature and it's nonlinear with respect to concentration also. So one way to do this, if possible, you can convert this nonlinear function into a linear function. How do you do that? You can take a log on both sides. Okay, let's take log on both sides. Now what will happen when you take log on both sides? This, you can separate this, right? It becomes ln k0. This is ln k0. This ln e raised to minus e by rt. When you do that, this minus e by rt comes out at the comes out at a coefficient. So minus e by r minus e by rt comes like that. And then log of c raised to n is what? That is n log c. Okay, this is how when you take log on both sides, this equation will come to be this equation. I hope you guys are clear with this expansion. Okay, now what you do is instead of fitting temperature and temperature, so in earlier our table was like this. We had a C, we had T value, and corresponding you have the rate value. Okay, now you know that this is not linearly related. Now what we do is we create a table of 1 by T. Okay, so first let it be, so we'll create a table of L and C, 1 by T and R. When you do this, what will happen? With respect to 1 by T, this is linear. With respect to L and C, this is linear. Okay, now you can fit this linear data using method of least squares. So now it will come like this. Y is equal to A0 plus A1x plus A2u. This is your linear equation, right? This is your linear equation. Okay, here what is Y? Y is ln R. Okay, A0 is what? That is ln K0. X is what? That is 1 by T. U is what? That is minus ln C. So when you get this and when you find A0, A1, A2, what is A0? It is ln K0. So if you want to find K0, it has to be K0 is exponential A0. Okay. And A1 gives you what? A1 gives you minus E by R. And A2 gives you N. Okay. So the coefficients will be like this. Okay. You get K0 from here, you get E by R from here, you get N from here. So that's all the unknowns here. The unknown here was K0 was unknown, E by R is unknown, N is unknown. You will get all the functions here. Okay? All the values of this unknowns. Okay? Is this concept clear? Shall we try doing this right now? Okay. Now let's try to do this. So already the table has been made. You don't have to worry about all this. So I'll just tell you how the table looks like. This thing. If you want, you can directly enter one by one. Okay, that's completely fine. But finally, your X data and Y data looks like this. X data is like this. Okay. This is your moles per liter concentration. And this is the temperatures. And the Y data corresponding to the combination is, that is the reaction rate is given here. So this is your X data and this is your Y data. Okay, you have made the tables like that properly. Now, what you have to do is, you have to find X. What is X? X is 1 by T. Okay, in this X data, temperature comes in the second column. So what do you do for calculating X? You take 1 divided by the second column. Okay, this gives you 1 by T. This gives you 1 by temperature. Okay, next is we have to calculate log of L and C.
Excuse me, ma'am.
Yes.
Hello. Ma'am, in that first part of the code, where they've given like C is equal to rep mat, C comma 5 comma 1, and
Uh,
also the next line. Can you explain that, ma'am? How we have taken that code?
No, so what this was done is, see, either you can see the table was very big, right? Whatever was given to in the PPT, the table is really big. What you can do is, one way is you can manually write X data and Y data. Looking at the table, you can write it. Okay, that is one way to do it. Other way to do it is, this is a small trick which might not be applicable in all the cases. In this particular question, you can do this trick. What is being done is, you know what to see. You only have four values of concentration, 1, 2, 3, 4 in the table. Okay, and temperature also you only have these many values. Okay, that is 400, 450, 500, 550, 600. Now what I do is I repeat this. Okay, I repeat this 1, 2, 3, 4 multiple times. So if you can see here, you can see 1, 2, 3, 4. Okay, this is 1, 1, 2, 3, 4. Again 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 1, 1, 2, 3, 4. I can repeat the same entries. Okay, that's what the C does. I'll just show you, run and just show this to you. Okay, it will repeat 1, 2, 3, 4 like that. So rep mat is for repeating a certain thing, that is C matrix, C vector is repeated, and it is made into a five times is repeated, right? 1, 2, 3, 4, 5. 5 times is repeated along the row. Only one time it is repeated along the column. Okay. Now what I do is I have to rep mat. So this thing I'll show you. This is T is also a square. So T is like this, right? It is a row vector. So first I'm converting this into a column vector. Sorry, for T is a column. First I'm converting into a row vector. So T dash, what does this do? T dash is like this. Now I again rep mat T 4 times. See, it became like this. 4 like this. Okay, 4, 450. I'm repeating it 4 times with respect to the row, 1 time with respect to the column. So this was repeated like this. Now I reshape is for reshaping. If you have a matrix, it will be reshaped. If you give this is how they decide how to reshape it. It will have 20 rows, 1 column. That's how this reshape works. So when I reshape it like this is what is happening. Okay, this whole 400, 450 extra will be reshaped like this. Okay, if you want to know how this reshape work, you can just type help reshape, you'll understand. This has certain rules by which it goes. Okay, this it'll have certain rules by which it goes. So if you are reshaping x m comma n, it will return an m by n matrix whose elements are taken column wise. Okay, so it will go column wise from here. Column wise means this is your first column, 400, 400, 400. Next column will be 450, 450, 450, 500, 500, 500. So it will be repeated like this. And finally, as said in the question, I will be getting a 20 row, 1 column matrix. Okay. So now basically what happened is, if I run the whole thing here, Okay. My C is looking like this. 1, 2, 3, 4 repeated. Okay. And my T looks like this. 400, 450 again repeated. Now I combine this thing. I get X data like this. 1, 2, 3, 4 repeated, and the 400, 400, 400, 450, 450 like this, it has been repeated. Now what I do is this Y data, so the R vector is already there. Okay, the R, this is in the form of a, so how does R looks like? Let's see. Okay, R is a matrix like this, which I have to again reshape it so that it forms a column. So I'm reshaping R to 20 rows, 1 column. Okay, so finally I'll get Y data like this. Okay, so now this is how what I did is I reshaped my X, reshaped my Y. You have to be very careful. That is, for a certain combination of C and T, the corresponding R should come. Okay, like when you reshape it, it shouldn't be that R should be jumbled. For this particular C and T, you should get the correct R. Okay, so that was a small trick that was used here instead of coding it one by hand. Is the doubts cleared?
Yes, ma'am. Yes, ma'am. Thank
Yeah.
you, ma'am.
Yeah. So now what we do is we have to have, so as I said earlier, this will give you 1 by T. This will give you L and C. As we have said previously also, a log in Matlab means natural logarithm. If you want log to the base 10, you have to use log 10. In Matlab, this is the code for doing that. Okay. So this is a natural logarithm. Now n is nothing but the length, how many entries I have. Now I have to make the method of least squares. What I have to do, I have to make the matrix, right? So in the matrix, first every value is 1. Okay, so that is 1, n times I'll have ones. Then is my x data. So my x data here is 1 by t. Okay, and my u data, which is L and C. I have my x matrix here. Okay, and my y is nothing but straight away the y data itself. Now, how do I calculate phi? Inverse of x transpose x. So whole inverse of x transpose x multiplied by x transpose y. I'll get the phi. As I said earlier, phi is nothing but your first phi is what? Here you have to, if you want to get k0, you have to take it back. Okay, so that is exponential of phi 1 will give you k0. Okay, minus e by r was your phi 2. So if you want to get e by r, you have to take the minus. And phi 3 directly gave me my n value. So that is automatically my n value. Okay, so this is how you calculate an unknown. You get k0, you get e by r, and you get n. You have to reconvert it back because for making it linear, you converted the whole data, right? So when you get your phi values, you have to convert it back to your actual variables. So like remember this point. If you don't want to do this, okay, if you don't want to go through all these hurdles, there's an inbuilt MATLAB command for fitting nonlinear functions directly itself. Okay, that function is called as LSQ nonlin. We'll look at the syntax of it. Yeah. So this is syntax of LSQ nonlin. So phi, which is the unknown quantities, LSQ nonlin is a keyword, and you're telling it is a function of your unknown quantity. Phi is the unknown here. And F name, you only give the unknowns and you have to give an initial guess for the unknown. Okay. So phi is the parameter vector. P0 is the initial guess for this parameter vector. And what does this function give? This function earlier, you remember in LSQ curve fit, the function gave the model itself, model function itself. But here the function should output the error value. That is, this is the model function. So earlier what we did is in LSQ curve fit, you only had this portion, model function. Now what you have to do is this function should output the errors. That is yi data, which is given to you in the question, minus your model. Okay, so that error should be the output that is given. And LSQ nonlinear also minimizes the error. So let's try to do this. Just give me a second. So this is the function. I have here 3 phi values, right? One corresponding to k0, one corresponding to e by r, other corresponding to n. There are 3 unknowns. So I'm just giving an initial guess 101. Okay, for all these 3 unknowns. LSQ and nonlinear. This is my function value, a reaction function. Let's see what is happening in reaction function. It will take phi, it will take x data, y data. And I'm telling the first phi value is k0. second phi value is E by R, and the third phi value is N. Okay. And X data is nothing but my concentration. Straight away, I'm taking concentration. I don't have to convert it and all to log C and all. I don't have to convert. I'm straight away taking concentration. And my second data, I'm taking it as temperature. You can jumble it also. It's completely fine. But make sure you write the function properly. And this is my model equation, K0 exponential E by R divided by T multiplied by C raised to N. This is the model function given to me in the question. Now, what will be my error function? That is Y data that is given in the table minus what is given by the model function, minus R. So this FERR comes as the output here. Okay. Now going back, that is A0 X data, Y data. This will give me the error. I am taking the initial guess. Okay. Now let me run this code. You will see this is the portion where this function is running. Okay, LSK non-line local minimum has found. The answer has been found out. So now let's see what is your phi value. Okay, phi I. Okay, what is it? Fill. Okay, this is your phi value. So this was K0. This is E by R. This is your N value. Let us compare to whatever we got earlier. Okay, this is what you get earlier from your linear least squares. Okay, E by R, what we got earlier was 480,1366. Here we are getting 485,8177. K0 earlier we got 4.8085. We are getting 4.8433. N value earlier we got 0.7479. Using this method, we are getting 0.7524. Okay, there is a slight variation. Okay, that this is possible because you're solving using LSK non-line, and when you solve using this method, there is a slight possibility the values might change because this function is not linear. Okay, linear functions you almost get exactly the same fit when you're using LSK curve fit, and when you use like linear regression, you will be getting almost the same fit. But for non-linear regression, this slight discrepancies are possible. Okay, but you get the range of values which is correct. Okay, so this is how you solve it. Any doubts? Okay, if you don't have any doubts, let's go on to the next topic. So far we saw about how the regression has to be done. In interpolation, we only did the neuter divided difference, right? Now we have a two inbuilt MATLAB functions for doing interpolation. That is called as a spline interpolation or the p-chip interpolation. Spline interpolation stands for cubic spline interpolation. This you would have seen it in Max also before. Now p-chip, it means piecewise cubic Hermite polynomial. You don't have to go through the mathematics of it. I'll just tell you how to use it, okay, for interpolating. So for example, you have given the X data and Y data. The user is asking you, find me the interpolated value for this X value. So X value will be a vector of values. I need to find what is the interpolated Y values for that. So this is the syntax. This is the output. You should be getting the Y values for the corresponding X value. So I'm calling that to be Y interpolated. I can use any other variable name also. Spline is the keyword. X data and Y data is given to me in the question. And X val is where I need to find the interpolated values for. Now, X data and data is the data vectors. Y interpolated are the values interpolated at X val. Okay, so this is a syntax. This is a syntax for spline. If you want to use it for p-chip, you can just replace this word spline with p-chip. Okay, the syntax remains the same. So now we have an example, temperature variation in a day. Okay, so that is we have your time going from 0 to 24. Okay, I think it's for hours, 0 to 24 hours. You have your time varying, and your corresponding temperature is also varying from 25.6 to 26.1. So we need to find the interpolation. Just a second, I'll share Matlab. Just give me a second. So this is what is happening. I have here temperature is given here. Okay. And my hours goes from 0 to 24. This is 0 colon 24, which means 0 to 24 it will be a vector with a step size of 1. Okay, let me clear all this. Clear CLC. I'll run this here. Okay, what we will be getting is H, that is hours. It will go from 0, 1, 2, 3, 4 up to 24. And temperature also, it will be given according to the question, it will vary. Okay, so 24 entries I have. Sorry, 25 entries I have. Now what I have to do is I have to interpolate and find what is the temperature at this following hours. 2.5 hours, 6.5 hours, 10.25 hours, 7.17 hours. So these hours are not there in my H. Okay, I only have 0, 1, 2, 3. I only have whole numbers. Okay, so for I need to find what is the temperature at this particular hours. So what is my syntax? This is my output. Temperatures will be saved here. Spline is my keyword. I take the H and X data and Y data that is provided to me in the question, and this is the hours at which I need to find the interpolated data for. So this is my spline keyword, and I'm just printing it H and TI together. It will be printed as a matrix here. I'll run the whole thing. So this will be the answer. For 2.5 hours, my temperature is 24.9790. For 6.5 hours, the temperature is 26.1307. For 10.25 hour, it is 30.92 degrees Celsius. And for 17 hour, it is 31.80. Okay. Now, if you want to know if it is confirmed, if the answer is true, you remember the 17 hours will be there in our data set also. Okay, right. So for 0 to 24, you will have for the 17th hour will data will be there given to us. So let's compare. Let's compare to the table. Just a second. So 17th hour, yeah, 17th hour. Okay, the data value is 31.8. Let's confirm if you are getting the same answer. Yeah, 17.5, 17th hour, you are getting 31.8 itself as answer. Okay, so your interpolation is working fine only. Okay, and you get what is the intermediate temperature at the intermediate hours. Any doubts?
No, ma'am.
So now let's look at one more example. So that is a vehicle speed in front of a government hospital. So from time in seconds from 0 to 90 seconds, the speed of the vehicle is varying. First it is 45, 32, then the vehicle is stopped. So it's like 0, 0, no speed is not there. Then 7, 12, 20, 15, 25, and finally it is 55. The speed is varying. Okay, it's a non-linear change. So we need to find the interpolated values. So let me go back to the Matlab. This is the code. So your time is varying from 0 to 90 with the time step of 10. Okay, so that is your 10. That is your time. That is as per given to you in the question. How to work with Matlab keyword spline. I've got a question. So that's what I said. I'll explain it once more here. This is your t value, time value given. This is your speed values that are given. Okay. Now let me just plot this and show you how my time and speed is. Okay. Just a second. I think my Matlab is kind of stuck. Let me clear it here. Let's see. No, this is it's a problem with my display. Just give me some seconds. Yeah, this is how my figure will look like. So it's a scattered data. As I said, the temperature, sorry, the vehicle speed is initially coming down and then it is a 0 for some time and it increases. So it's a non-linear change. You can't fit, it's like fitting a straight line to this, it's not a good match. Okay, so you have a non-linear behavior. So now what I do is I need to interpolate the data. For interpolating the data, I have interpolated it for like here, the data is with a time interval of 10 seconds. So let me interpolate in such a way that my time interval is just 1 second. Okay, I can use any other difference also. Right now, I'm just interpolating it for at a very fine grid. That is from 0 to 90. It has to go from 0, 1, 2, 3, 4 with a time step of 1 till 90. Now, this is how I use the spline keyword. Okay, this is the output. That is for this time. What is my speeds? So that will be saved in this SI vector. Spline is the keyword that I use. I take the time and the speed data that is given to me in the question, T and S. And this is the times at which I need to find the interpolated data for. That is TIs. Okay, I run this. Okay, now I plot this data. So that is TI and SI. I'm plotting it with a black solid line. K dash K means dash corresponds to a solid line and K corresponds to a black line with a line width of 1.5. So I'll do this together. I'll get a curve like this. Okay. So this you can see this how the scattered line is. Interpolated curve should always pass through all the data points. Now what I did is a spline interpolation. So that is why you can see it is being a curved path that is passing through all the data points. Okay. Now if we need to find this SI, sorry, TI is like this 0, 1, 2, 3 like that. And the SI will be corresponding to 45, 46.6. You'll see how the behavior is. Okay. Now the same thing, let's see how to use P chip. So for the P chip, as I said earlier, the syntax is just the same. Instead of spline, you have to just use the keyword P chip. That's only difference. So just so that my variables doesn't get overwritten, I'm just writing SI underscore PC for P chip. P chip is my keyword. I'll give the time and the speed data that is given to me in the question. And I have to interpolate for the same time. That is from 0 to 90 with the time step of 1 second. Okay. I do this. Okay. And I plot it using dotted dashed red lines. Okay. Let me run the code together, only then you will be understanding the difference. So this is how it looks like. So with spline interpolation, you can see the curve is very smooth. Okay, it has like a lot of curves like this. It is curved. Now for the P chip, you can see you get a different curve, but that curve is also passing through all your data points. Okay, so there is a fundamental difference in which how spline and P chip differ. I'm not going to the mathematics of it, but visually how does it happen is for P chip there is a condition that when I'm joining these 2 points, okay, when I'm joining this point and when I'm joining this point, P chip has an inbuilt condition that is whenever I'm interpolating, the y value for that x points should always fall between this y values of my endpoints. I know it can be a bit confusing, so I'll just explain it once more. Okay, so for this point, my y value is something. What is my y value here? Let me see. 45. Okay, this positive y value is 45, and this point, my y value is 32. Okay, now you can see this curve. That is my spline curve is going like this, right? So at this point, my y value is greater than 45, right? At this point, what will be my y value be? It is 47. Okay, so this 47 is not between 45 and 32. So one hand I have 45, one hand I have 32, and 47 is okay, 45 and 32, and 47 is not between these two values, right? 47 is even higher than 45. But if you look P chip, the curve value is always between 45 and 32. Okay, so this is a condition for P chip. In P chip, what happens is your interpolated value is always limited by the two endpoint y values. Okay, so that thing you can see here also. Here you can see this value is 0, this value is 0. The y value is 0 here, y value is 0 here. So what happens, P chip should have a value that is being restricted by the y values at the two ends. So because of that, you get a straight line where all the y value is 0. Okay, on the other hand, you can see spline is going below. Okay, spline, it is a smooth curve. It goes below and you get a value for y as 0, minus 3.22 and all. Okay, that is not restricted by your end y values. Did you understand? So P chip is always restricted by the endpoint y values. On the other hand, spline is a smooth curve because spline has an inbuilt condition, like the how spline interpolation is done in such a way that wherever the data point is there, okay, here the gradient should be smooth. Okay, so here if you see here for the p-chip one, it has a sharp inclination like this. Okay, so at this particular point, that is at this particular point, the gradient is not smooth. But for spline interpolation, the inbuilt how the spline interpolation is done in such a way that wherever you have a data point, it should have smooth curves. Okay, so that is why you can see this spline interpolation curve is coming like this smooth one. On the other hand, p-chip curve is sharp. Okay, is this clear? What is the fundamental difference between p-chip and spline?
Yes, ma'am.
Yeah, you have to choose in such a way that that is suitable for your problem. Okay, in your problem, if you know that, okay, the y values have to fall between this criteria, then you have to use p-chip. If you know that, okay, that doesn't matter, you need a smooth curve, you need a smooth gradation of values, and then you have to use spline. It totally depend upon your application, which one you use. Okay, so let's look at a bit of theory of it. This is just for your understanding. Spline constructs a curve, like S is the name of the curve, in almost the same way as p-chip constructs. However, spline chooses a slope to make S double dash. That is the derivative of the gradient. Okay, continuous. This difference has several effects. The spline produces a smoother result such that S double dash. That's a gradient is the change in the function. Again, one more time we have to take the derivative of it. That is continuous. Spline produces a more accurate result if the data consists of values of a smooth function. Okay. If you know that physically this function will be a smooth function, then you have to use spline. Only then it will accurately match your physical in your real life problem. On the other hand, p-chip has no overshoot and less oscillation if the data is not smooth. P-chip ensures monotonicity. So this term is called as monotonicity. That is, new y value is between the y values at the interval length. Okay, this property is called as monotonicity. These two are equally expensive to evaluate. Okay, so there is nothing like, okay, one is expensive, the other one is less expensive. It totally depends upon your application. How is your real world problem behaving? Okay, depending on that, you should be using these two functions. Any doubts? If no doubts, let's move on to the one more example. So here we have a nonlinear function r is equal to a divided by b plus t. Okay, there are two ways in which you can fit this function. One is convert into a linear problem. Otherwise, you can directly use this function using LSQ nonlinear. How do you convert this into a linear problem? You can just take a reciprocal of it. So what is the reciprocal of this? Okay, if you're taking the reciprocal, this will be 1 by r is equal to, sorry, yeah. Reciprocal will be 1 by r is equal to b plus t divided by a. And if you take the, why is this coming like this? Okay, that is 1 by r is equal to b plus t divided by a. And that can be written as b divided by a plus t divided by a. Right? So this thing comes like this. You can convert this data. So now what will happen? 1 by r is your y value. Your new y value is 1 by r, and b by a is your other quantity. Okay, and a0 will be and the other quantity is 1 by a. Okay, so your first coefficient will give you b by a0 is b by a, second coefficient will give you 1 by a, and t is the variable. So first you can convert into a linear form and then fit it, or else you can directly use LSQ non-linear. Let's see both. Yeah, just give me a second. The problem is, okay. So first you have your time and your reaction. First I do 1 by r, t remains as such. I just check how many data points I have. I make my x vector. X vector will have all ones. That will be my first columns. And then it will be my next value, t, as such. Okay. Then I fit the curve using in the whole inverse of x into x transpose x multiplied by x transpose y. I get the phi value. But I have to convert it back. Okay. Converting it back, how do I get? A is nothing but, so if you remember, my second phi value, so my second phi value was 1 by A, right? So if I take the 1 by the second phi value, I'll be getting A. And the first phi value was B by A. So what I do is first phi value multiplied by A, I'll be getting the B value. I have to convert it back. Okay. So if I'm directly using LSQ non-line, I'm just taking an initial value of 10 and 10 for both A and B parameters. And I'll see how this LSQ non-fun is coded. So LSQ non-fun. Remember, this has to output the error. So it takes the phi value. This is my T value and R value. Or otherwise, you can input T and R here also directly, if that is also possible. I'm telling the first value corresponds to A, second value corresponds to B. This is my model, A divided by B plus T. And I take the error, model minus the R that is given to me in the question. I get this F error, and that is taken as the output. Okay. And now you can compare the values here. I'll run this. Okay. From the first part of the question, that is using linear fit, A is 9.425, B is 22.611. But using this phi value, LSQ non-line, my A is 9.38 and my B is 22.3985. Okay, so there is a slight variation in value, but that is okay. But you are getting values to be like almost equal. Okay, is this clear? Any doubts? Okay, if no doubts, let's move on to do some problems. Yeah, these are simple problems. As you know that this is linear regression. The concepts are like almost the same what you use, right? So here you have a multiple linear regression. That is, you have a function y is equal to c plus ax1 plus bx2. We need to find the parameters for a and b. Okay, you can use any method. If you want LSQ curve fit, you can use that. If you want to use the inverse of x transpose x multiplied by x transpose y, basically this formula. Okay, I hope you know the formula by now. If you want me to show that once again, I can show it. Okay, just take a screenshot of it. X transpose x inverse multiplied by x transpose y. Okay, this is the formula. So, yeah, this is a question. Let me know the answers once you have done. I'll give you a few minutes. Once you have got the answer, please put it in the chat box and then we'll discuss. Okay, I want all of you to do it. Okay, even if you don't have MATLAB also, you can do it with pen and paper. If you have a calculator, it will be done very easily. So try to do it and let me know the answer. Yeah, one person have answered the question. I want like few more people to do it, and we'll discuss in like 2-3 minutes. So let's discuss the answer. So first we need to create the X matrix. Okay, so X matrix, the first column will be all ones, then we'll have X1 and then X2. So let's try to do that. So here you have your X values, Y values here, sorry. Hmm, let me clear first. Okay, so first you have your Y values given to you in the question, and X data I'm directly writing it here as two columns. Okay, So my x values are like this. Now first I need to make the x matrix. That is, first I'll have all ones. Then I'll have the first entry, first column of this x data, second column of this x data. Okay, you can direct directly also. The x value x matrix can be written directly also. That is completely fine. So x will look like this. Okay, this is how your x will look. I think, uh, yeah, this is your x matrix. Now what you have to do, whole inverse of x transpose x multiplied by x transpose y. You'll be getting your phi value. Oh, sorry, I didn't run the whole thing. Yeah, you'll be getting three phi values. This is A0, this is A1, and this is A2. Okay, so I'm displaying it like this. So the function here had A, B, C. So your A value is your, if you go back to the question, so it is in the order C, A, B. Okay, so the first unknown quantity will be C, next unknown quantity will be A, next unknown quantity will be C, B. So the order C, A, B. So your A is nothing but phi second entry, B is phi third entry, and C is phi first entry. So this is how your A, B, C value looks like. Yeah, Vikash, you've got the right answers. Okay, good. So let's move on to the next question. Any doubts so far? Let's move on to the next question then. You have to use LSQ non-lin. This, so LSQ non-lin means you can directly give the model function. Okay. So remember, it has to be the error function first given. So this is the model function, and the initial guess for phi is 10 and minus 0.5. After that, you have to report what is the value of A and B. I'll give you a few minutes and then let's discuss the answer. I want everybody to do it. Once you've got the answer, please put the answer in the chat box. Yeah, two of them have given me answers. I can like wait for like 1 more minute and then we'll discuss. If anyone more there is there to answer the question, please do put it. Let's discuss the answer. So the model is A raised to BT. So there are two unknowns, A and B here. Okay. So let's try to do that. So the initial guess for phi is given as 10 and minus 0.5. This is your time and temperature data as per given in the question. So now we use LSQ Nodlin. Phi is the unknown. LSQ fund is the fund that I write. It takes in the data that is time, temperature, and also the unknowns. So the function is LSQ fund. Yeah, this one. So it takes in phi, time, and temperature. And out of phi, the first parameter is my A, second parameter is my B. This is my model A exponential BT. And for error, I have to calculate t minus the t model. T, which is given to me in the question, minus the model equation. So that is my output of the function. Now going back, I use phi 0 as the initial guess. And out of this phi, the first entry will be my A, second entry will be my B. So I display those correspondingly. Clear? Okay, I'll run this code. So the LSQ nonline has converged, local minimum is possible. So my A value I get it as 29.6865 and the B value I get it as minus 0.19783. So yeah, there is like a slight difference in value. Please check the code. And one more thing, uh, I want to emphasize this. Whenever you write this function, right, like see, you can't straight away multiply B and T because both B and T are vectors. Okay, so you have to use dot star. So wherever you are not multiplying a scalar, so if you're working with a vector, sorry, I think here this is fine because B is a scalar, okay? But wherever in your model function, if you have both, yeah, we have to take element wise. So wherever you have this multiplication, it is better you use element wise multiplication. Element wise multiplication with scalar also, it works the same way. So whenever you have multiplication in your model function, please use element wise multiplication, okay? Yeah. So that's it. If you have got the wrong answer, please to check the code again and compare if you have written coded it the right way. Now this is the second problem. Sorry, the third problem. It's a regression problem here. It's the same thing. That is this problem itself. It has been extended, so you can use the same t and the time and temperature values. Just that in this case, you are converting into a linear problem. That is here t equal to a e raised to bt. You are taking log on both sides. Now it becomes log of t is equal to log of a plus bt. Your first unknown is ln A, second unknown is B. Okay, remember you have to use the method of linear least squares here, but you have to convert back your phi values. Okay, if you have to get your A and B values. Yeah, Mehet, right now are you getting the right answer? If you have doubt, please put in the chat box. Okay, we can discuss it again if you want. So this is the same problem. It's just that it has been converted into a linear regression and report the value of A and B. Remember to convert it back properly. So I'll give you 2-3 minutes and then we'll discuss the answer. I've got some answers. Yeah, I can give you 2 more minutes and then we'll discuss. If there are more people to answer, please do put it on the chat box. We'll discuss the answer soon. So let's discuss. So since it's the same problem, we should be getting a parameters close to what we got earlier. Okay. So let's look at, so let's, sorry. So let's look at the problem 3. So this is your T and the time and the temperature. So you have to take the log of temperature and the time remains as such. So first I'm making the X matrix all ones and then the X values. Okay. Then I take whole inverse of X transpose S, X multiplied by X transpose Y, and I have to convert it back, right? So from the phi value, I have to take exponential of the first phi value to get A. B is as such, the second phi value. So let me just run this code and we'll compare. Okay. Earlier I was getting A to be 29.6865. Now in the new problem I'm getting A to be 29.3839. My B value earlier was 0 - 0.19783. Now my B value is minus 0.19265. 267. Yeah. Because you've got the right answer. I hope others also have understood. Okay. So let me just move on to the next question. This is an interpolation problem. So the population of the city starting for particular years are given from year 1980 to 2020. Use this table and try to find the interpolation for the year 2009. Okay. So either if you want, you can just give from 1980 to 2009, you can give a vector of values, or you can try with 2009 just as a single entry also. Okay. Try doing that. You can use both spline or pchip. Uh, and you can let me know the answer in the chat box. Okay, we'll discuss the answer. Yeah, I've got an answer. Let's see. Okay. So for interpolation, so this is the year and the population given. So I can, if I want, I can create a vector from 1918 to 2009, or else I can give 2009 only. Okay, that is also possible. So what I'm using it, I'm using spline interpolation, Y, P, and the years at which I need the interpolation. Then I get the population corresponding to all the years. Now, for particularly for 2009, what I can do is it will be the last entry because my last year is 2009. So here in the population, my last entry will be the population corresponding to 2009. Okay, so let's see. Let me run this. You'll be getting 152047. Yeah, yeah. You'll be getting 152047. That is the exact population. So let me see what will happen if I just give 2009 itself. Uh, okay, I will run it again. Yeah, again I'm getting the same answer. Okay. So here if yi is just 2009 and the population is 152047. Okay, just check you have given the y value and the population correctly. It's a fairly simple problem. So using p-chip, you will get a different answer probably. I'll just try p-chip also once. Okay, using p-chip, you are getting 152113. It's not a whole number. So this doesn't make sense, right? So you'll take this, whatever you're getting with spline, 152047. Now let us move on to the next question. So this will be the last question of the day. Again, it's an interpolation problem. You have to interpolate using both spline and p-chip and compare the answers. Okay, you can also use a plot. So what we need is you have this data. We need to find the data at x is equal to 2.98. You have to use both p-chip and spline, and you have to tell me the answer for both the interpolation. Okay, 2.98 x value. I'll give you 2-3 minutes and then we'll discuss the answer. We've got some answer. So let's discuss. So you have your values changing from -3 to 3 with an interval of 1. So I can directly write like this, or else you can write it as a vector also. And this is my y value. And I need to find value corresponding to a particular point, that is 2.98. Okay. So since I have to plot, right now I'm just taking -3 to 3 with the interval of 0.01. I need a very finely grid plot. That is why. I'm using p-chip and spline. Okay, since it is still 3 and it's a difference of 0.01, 2.98 means it will be my third last. Okay, that is if I keep end, p end means I'll get the interval when I'll get the y value at x is equal to 3. N minus 2 means it will be 2.99. Then the next value will be 2.98. Okay, n minus 2. I can do like this also, or if you want, you can do the plotting p-chip separately. And you can do for 2.98, you can write another p-chip separately. Okay, 2 lines of code, that is also possible. So right now I just did it in 1 line of the code, both the plotting and what is the value at 2.98. So the syntax remains the same, x, y, and wherever you want to find the interpolated value, spline x, y, and wherever you want to find the interpolated value. I'm plotting x and y, the scatter data. This is for my p-chip data, and this is my spline data. Okay, so let's see. So this is how my curves looks like. You can see how it is. So here my xy value is -1. Here my y value is -1. So since I'm doing p chip, it will be a straight line connecting this. But on the other hand, spline will have curves. Okay, so the curved line that you see is the spline, and the smooth line, which is like horizontal here, that is the p chip. Now let me look at the value. If I'm using p chip, my y value is 1 at 2.98, and if I'm using spline, my y value is 0.9903. Yeah, you've got the right answer, Vikash. I hope others have also understood what we have discussed here. If you do you have any doubts? Okay. If no doubts, that's the end of today's session. We'll meet this Friday again for the this week's recorded lectures, discussing this week's recorded lectures. Sorry, I couldn't take last Friday the class. Sorry for the inconvenience, but this week we'll meet again. Okay, so that's it. Yeah. Thank you all, especially for the ones who are answering, being active in the class. So, yeah, we'll meet again on the Friday. I'm ending the session today. I'll be uploading the recorded lectures. Yeah, yeah, thank you everyone. Thank you all for attending today's session. I'll upload the recording lectures and the PPT soon. Okay, yeah, thank you.